Hey Katie, good afternoon. I am getting your algebra homework videos done right now, and this is the first one, and it will walk you through factoring every kind of trinomial. So where we left off last session was with the classic trinomials, the x plus y whole thing squared, x plus y times x plus y, going to x squared plus 2xy plus y squared, and then the negative version of the same. So I'll let you look over that if you have any difficulty, or stop the video. That's the nice thing about videos, is I can teach a little faster than normal because you could stop it and watch it a couple times. Don't forget on trinomials to try to find a common factor. Like in this instance, we have 6x squared plus 12xy plus 6y squared. Here, let me zoom in a little bit so you can get that. Okay, well, you can see that in each term you've got a 6, and if you factor that out, like right here, you see that a classic trinomial emerges. We have the x squared plus 2xy plus y squared, which we might remember from up here, which is the x plus y whole thing squared factor set. Okay, well, when it gets a little bit difficult, one of the first things that you want to have under your belt is the plus and minus patterns that you might encounter. This technique we'll call winging it, and that's what we'll mostly deal with in this video, is winging it. Over here we've got the terms, like right here we have the 6x squared term plus the 12xy plus the 6y squared as an example. The signs from that are plus and plus, just like our first example here. Plus and plus, if that's what the terms are, the factors are going to be plus and plus. If you have a minus and a plus, then the factors are going to be minus and minus. If you have a minus and minus, the factors are going to be plus and minus for sure, but the minus term, whatever comes after that in the factors, so let's say we had, x minus 5, the minus term, the minus 5, has to be bigger than the other term. Let's say the other term was x plus 3. In this case, the minus is bigger. So the minus has to be bigger if you started off with a minus minus for your term set. If you had a plus and then a minus, well, you still have a minus and a plus, or a plus and minus. It doesn't matter the order, except that the positive one, the plus factor, would have been bigger. So here we can change our example to plus 5 and then minus 3, and that will make things work out right. Okay, so the first thing that I want you to do is memorize those patterns. They will make the harder scenarios much, 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 much easier if you have them memorized. Also, I'd like you to note that in these bottom scenarios, right here, the minus and a plus and a minus, you really don't want to see them because, as we're going to talk about later on, they're a difference of sum. Difference of the factor sum. Okay. Let's still keep on talking abstract stuff and say, what do you do if you have no common factor? We already talked about an instance where if you had a common factor, you can factor it out, and it may be that a classic trinomial emerges. Let's say that doesn't happen. Here's the thing to do. If z is your first coefficient, o is your second, and u is the last one, the coefficient term with no x in it, let's say z and o and u are all ugly. The first thing to do is look at all of the factors of z and u. List them out. So step 1, make a factor tree. You make it for z, you make it for u. So always 1 and the number itself is a factor, and then it's going to have several other factors, and they can go on forever or whatever. But let's just say we only have 2. The factors here are z1 and z2. The factors over here are u1 and then u2. There's props to Bono there. If that's the case, what I would like you to do when I say list them is to just make kind of a box with them all plus or minus whatever multiplies to make the big Z. Same over here, make a box with all the ones that make u's. The plus and minuses are here for the practice example. You should probably be in the habit of doing that at first, just because you need to think that there are negative options here. After you've done several of them, I'll stop writing the plus and minus ones, but for these first couple examples I'll just keep on writing it out. Step 2. Check the last term for a plus or minus sign. So over here in our hard trinomial, we've got a plus sign. That's good. That means that we're in scenario 1. The plus sign means that you add the factors from 1 once you've multiplied them together. The minus sign would mean that you subtract the factors from 1 once you added them together. And when I mean 1, I mean the factors you got from z and u. You might recall that we tipped you off to that right here at the top, where we said, hey, in these bottom two scenarios, you have minus signs right there and there. You need to find the difference of the factor sum. The final step is multiply the pairs of factors and then sum the results to equal the O term. This may look like a 0, that's confusing, but it's actually an O because it's the OX term. So whatever the coefficient is in front of the x, you need to sum the pairs of factors to equal that. I'm figuring you're going to need some examples and not just deal in the abstract. So here's the simple version. This is actually kind of nice. You don't have an initial term, nothing in front of the x. Like here we have x squared minus 14x plus 49. If this is the case, you're going to have two terms, and we already memorized our sign things. If we have a plus and a plus, you will recall that you get a plus and a plus in the factors. You need a term here and a term here to multiply together to make c. So d1, let's say, times d2 equals c. Okay? Any numbers. And d1 and d2 are factors of c. So I have c, and I factor it out into d1 and d2. You also need d1 and d2 to be things that add together to make b. So d1 plus d2 equals b. There you go. All right, so let's solve our example here. We have nothing in front of that, so we can skip that number, go straight to 49. It's like factoring u. So 49 can be factored into 1 and 49, 7 and 7, and that's it. Okay, so we look at the sign now and we see that it's a plus sign, so we're going to be adding our factor sums. And since there's nothing else to multiply it by because there's no coefficient other than 1 in front of that, we're going to have two scenarios like this. We have a plus term here, but we have a minus term there. So we need a minus and a minus to make that work out. And we have a 7 here and a 7 there, an x there, and x there. So x times x is x squared, x times negative 7 is negative 7x, but negative 7 times x is also negative 7x. We sum these together to get negative 14x, working that way, and then we multiply negative 7 times negative 7 to get 49. So that's how you do easy winging it for the simple version where you have no initial coefficient right there. It's just 1. All right, the harder version. I actually started to work on this problem, and I'll actually finish it in a second. But I realized all of a sudden it's a bad example because it has a negative sign. That's the hard version. That's the one you don't want to see because it puts you back here at the difference of the factor sum, which is a little more complicated.